Welcome, welcome, welcome. Good afternoon, everyone. Just giving another moment for the Facebook live stream to get online and for everybody to hop into Zoom. Looks like we've got the better part of 50 people here this afternoon. Thanks for taking the time to visit with us. All right, looks like we're all stable. Let's get started. Welcome to today's Spirit of Aviation Week event. This session is entitled Planning for Success, System Design and Layout of Your Dynon or Advanced System. So this is a little bit more of a technical presentation than some of the others that we do. Our presenter today, David Weber, is an expert in all things Dynon. He's an A&P. He's built a couple of airplanes, one from plans. He'll be telling you more about himself in a bit. And so this is, once you've decided to build a Dynon or advanced system, there, we have great documentation and videos and whatnot, but David's put together a great seminar, really covering a large, most of the build process, things to watch out for, considerations, how to end up with a successful build and installation in a minimal amount of time and as quickly as possible. So, and you all probably know because you signed up for this event, but this event is part of our kind of Oshkosh replacement programming. Behind me, this is what our booth would normally look like if we were visiting in Wisconsin this week, but we're not. But we've set up a week of exciting forums and virtual booth visits. This is the second. Yesterday, we did an EA forum, which was focused on Dynon certified equipment. Tomorrow is Advanced Flight Systems Day. We will be covering the AF5000 series at 2 p.m. and then 4 p.m. Like now, Advanced Panel, which is the product where we can build you a ready-to-install panel featuring Dynon or advanced EFIS systems. Friday is a virtual booth visit where we'll literally stand up in front of a Dynon panel and demonstrate how everything works as if you came up to us at the Dynon booth at Oshkosh and say, hey, tell me about Skyview. And then Saturday is what we call a hangar happy hour. Pretty casual, not super programmed. We'll have drinks in hand and we'll just talk about airplane avionics and answer your questions and probably have a guest or two on board. So with that, the way this works is you're all currently muted. You probably figured that out if you've tried to talk. To ask questions, and we do have I have a couple of colleagues, Jeff and Kyle, that are helping answer questions both in the Zoom chat. So if you have the Zoom client, there's a chat box. You can click the chat button at the bottom of the screen and type your questions there, and we'll try to answer those. Also, if you're watching via Facebook Live, there is a comment stream, which you can ask a question there. And what we will do is we'll stop periodically to answer questions. There's a couple of breakpoints in the presentation, and you can either put the questions in the chat, or you can raise your hand at the bottom or in the participants. Under the participants button, there's a raise hand that you can use if you're on an iPad or phone. I think it's under the 3 dots menu. These videos on my phone. And if you raise your hand, we can call on you. We'll ask you to unmute yourself, and then you can talk to us and ask your question that way. And I think we'll test at least the chat portion right now. We're going to give away a $50 Aircraft Spruce gift card. And the way we're going to do that is starting now, you're going to type in a number, one per person, please, a number between 1 and 100. And in probably 20 or 30 seconds, I'm going to spin a virtual wheel, and the person that gets it, or that is closest without going over, it's a Price is Right rules, will win the Aircraft Spruce gift card. And for Zoom people, so everybody just stop with your final answers. And we'll spin the wheel in just a few more seconds. The Facebook Live feed runs about 10 seconds behind, so I'm just gonna vamp for a couple of seconds. I'm gonna share my screen. We have the virtual wheel. All right, so you should all see the virtual wheel of numbers. And here we go. Do we have a 41? Let's see.
Looks like everybody on Facebook, Mike, went over.
Okay, I see there's a 42. That was John. Let's see, anybody else get the 41? Oh, there's another 42.
42 is the closest one I saw. I don't think there is a 41.
There's three 42s. All right. You're all winners. So, so Jeff, if you want to collect, there's 3 42s. Hit them up and private message them, and we'll get your contact information, and we'll send you your prize, a Aircraft Spruce gift card, $50. So congratulations. And on that note, let's see. Yeah, I already kind of introduced David Weber. He's how long have you been with us, David?
10 years now.
10 years, wow. So you're an old timer like me. He's a mechanical engineer, a passionate home builder. The Sonics that you see in his virtual background, which I guess that's parked at Oshkosh, probably, was that on the way to the Dynon booth, or how did you end up at
I had just got done flying Fifi, and I was going to let the pilot from Fifi fly my airplane. So
a little.
No, we were waiting to fuel up to head out after Oshkosh, and I took the advantage of Fifi parked there to put my airplane in front of it and snap a few pics.
Gotcha. So David Plans built that airplane and sold that a few years ago to make way for his RV7, which is nearing completion. And with that, I'll turn it over to you, David. And thanks for hosting today.
All right. Thank you, Mike. Thank you for that great introduction, and welcome to everybody online. And thank you for attending this. This is a first for me. I've never done something on the web. I've given this presentation several times at Oshkosh in the forum tent, and things go pretty well there. But here, I don't get the advantage of my hand talking that I do during the forum. So I've tried to add a few more pictures in the presentation to help with that. So I'm going to ask you to use your imagination a little bit on some of them. It's very hard to do real technical things over the internet in an internet presentation, but we'll give it our try. Feel free to ask questions through the messaging. We've got a couple guys, Jeff and Kyle, will be answering those questions as they come up. And Mike will be coming in whenever my experience and knowledge isn't enough to handle it. And we'll go from there. So I will give me a second here to share my screen. And we'll get started with that presentation. All right. Everybody can see what we're going on here?
Yep, you're good.
All right, so Dynon, planning for success, system design and layout. The whole purpose of this presentation isn't to answer every question that you could possibly have in planning your system or installing your system, but it will give you some fundamentals, some very good fundamentals on doing that installation. I totally expect you to ask questions. I would ask that you do further research. Dynon has a great, a lot of different paths and different ways that you can get more information, and I'll kind of touch on that in this presentation too. So a little bit about myself here. I'm an engineer at Dynon Avionics, as Mike said, been there for 10 years. Believe it or not, 10 years ago at Oshkosh, I was told that I got the job at Dynon. So that was a pretty good Oshkosh for me. I am an A&P. I have a private pilot's license, over 900 hours. Done over 100 Young Eagle flights in my lifetime. And I highly encourage anybody out there that hasn't done a Young Eagle flight, do it. It is very rewarding. You cannot believe the reward you get seeing those kids' face when you take them up. As Mike mentioned, I did build a Sonix from plans that took just almost 7 years. In 2012, I flew it to Oshkosh and managed to come home with some hardware to hang on the wall. My son, I think, was a little bit more excited about that than I was, but of course he had helped me build it. I called him my automatic rivet or hole deburring machine. I highly recommend an automatic hole deburring machine, except they're quite expensive. Of course, he's 24 now, and very proud of that kid. Glassair Sportsman team build. A bunch of us at the office got together and decided that it would be a good idea to build a Sportsman for our flight, and we do use it for flight testing quite a bit with the Dynon stuff. It's a great airplane. We love that airplane. I am currently building an RV7, and I'm 90% done and 90% to go. It's a common joke, but I'm sure a lot of you out there can sort of relate to my feelings there. Seems like you can never quite get done with it. I am an EA technical counselor. I do a inspection on an airplane at least, I'd say 2 or 3 times a month. I learn a lot doing that, and I hope to educate people that are not quite as involved in aircraft construction as I am. I'm a senior hardware designer for the Skyview Classic Touch, the Skyview HDX. That was probably my biggest project at Dynon. I did all of the industrial design, mechanical design, everything from the bezel to the buttons on that. Dynon DRX, all the mechanicals on that, the Dynon D3, and I have recently transitioned into the Dynon certified STC side of the company, doing all the design work on the autopilot installations and panel installations for that group. All right, let's get into this. Planning for success. I'm going to give you an outline of what we're going to talk about today. Before you buy, system components, installation fundamentals. We're going to talk about panels, ADAHRS, remote compass, an EMS module, GPS receiver, and then a little thing I call hold my beer and watch this. It's basically some things you should do before you take that first flight. I'm going to give you some tools for success. I'm going to talk about what I didn't talk about, missing in action. And I'm going to give you some information resources. If there's one bit of a slide that you might want to take a screenshot of or take a picture of, it's that one right there. It's going to have a lot of information on it for you. All right, before you buy, I get this question quite a bit. People say, hey, what do I want to put in my plane? And my question back to them is, well, before you buy, you need to define your mission. What is that mission you're going to be doing with your aircraft? Are you going to be flying VFR, strictly VFR? You have no plans of ever flying IFR? Or are you going to do an IFR kind of airplane? If you're going to do an IFR kind of airplane, then your planning for your panel and your entire airplane itself is going to be quite different. Now, one of the nice things I kind of coach people on is maybe that thing where you grow into that panel. Maybe you start off with a VFR panel and VFR type of system, and you gradually morph into an IFR. And the wonderful thing about glass panels is that they are very capable of doing that. You can start off with something that's very basic and morph into a very complex system. And I'll get more into that in a little bit here. So ask yourself, what is that mission? That is the biggest, most defining thing that you should ask yourself before you even lay down a dollar where you're going on this aircraft. Of course, the next big thing is budget. What can you afford? A frugal budget, well, with a frugal budget, you could give yourself something like just a very simple single screen radio, 2-place intercom, or even if you don't have a second seat in the airplane, you don't even need that intercom. Very simple, very frugal, and Dynon has a whole bunch of different packages that allow you to get into that. And I guarantee you that what Dynon can get you into for a very basic VFR panel is just as competitive as if you were to put nothing but steam gauges in there. and you're going to have a lot more capability and a lot more expandability. Thing with the steam gauge is you put it in there and it's there. It has no expandability. You put a screen in a glass cockpit and that's got expandability as you grow on. You know, you leave that catalog sitting on the coffee table during Christmas time and circle that next component you need and just kind of shove it out there to your wife and let her know what you're looking at. It's worked for me a couple times. You should try it. So we're going to grow into that. Before you buy, you also want to do some product research and some system planning. Keep in mind, you're not just buying the product, you're also buying a company. A lot of people say, and my dad was absolutely wonderful at this, he would buy the cheapest thing he could possibly get, but what he didn't realize was that a lot of times that didn't come with things that you would get, like technical support. Does that technical support cost you money? Kind of history in our industry that a lot of companies will charge you to get that technical support. Dynon has never, Dynon will never charge you for technical support. One of the things that Dynon is very proud of is that when you call us, we pick up the phone. We have guys that monitor the forum. We even answer, I can tell you, Mike, I know, has answered plenty of questions on the weekends and on holidays on the forum. So Dynon is very active in that technical support that you need going through. How long has a company been doing business in the market? This is something else. Dynon's market is the experimental aircraft. It's our bread and butter. It's what we started doing years ago. We've never left that. We have no plans to leave that. Everything that we do experimental is in the thought process that we go through. It is the very first thing that we do. The vast majority of our resources are spent towards the experimental market. Is the company sound? Will it be there in 10 years when you need them? Think about that. Think about when you're buying that product. If you're buying from a very, very small company, are they going to be around in 10 years to help support that? There's several examples out there in the experimental world. Blue Mountain is an example that started off with a big bang, but didn't have the capital to keep them going. I can tell you Dynon is very well supported. Our ownership has been doing small businesses for years. He knows what he's doing. And if anybody knows the name John Terode, you know that he's very active in bringing the cost down to the aircraft market with the Vashon Ranger. And again, that's just John's skill. John knows how to run businesses. Dynon is not going anywhere. We're going to be around for a long time. What kind of warranty comes with the product? Well, Mike just ran away, so I was going to toss this to him. Maybe Kyle can do this for me. Kyle?
Yeah, I'm here.
Oh, there he is. Warranty on the products. Can you talk to the guys a little bit about warranties?
Yeah, in general, most of our major products, meaning like displays, ADAHRs, are 3 years from the date of ship. Engine probes and smaller items are less than that, but for all of the kind of the big ticket items, it's 3 years.
And what happens if after 3 years somebody happens to drive a screwdriver through their screen? What's the process after that?
Yeah, so we have on our website under the warranty page just a flat list of things, and it's all listed there, and it's broken down by product category, and pretty reasonable. And let's see, off the top of my head, I don't remember all of them, but for example, let's say like a major display or ADAHRs, it's going to be like a few $100s.
It's $450 for the most expensive repair fee for a display or something like that. Most other things are even more affordable than that. But the really nice thing people love about that is there's no surprises. There's none of that. Send us your equipment, and in a few weeks, we'll tell you how many thousands of dollars it's going to take to get it back in working order. You know what you're going to pay going into it. You have a good sense of how much time it's going to take, and it's really straightforward.
And it doesn't matter if you're the first owner or the 10th owner when it comes to that kind of stuff. Does the company try to communicate with customers? Well, I think we're doing a pretty good job of it right here, right now. I've been doing forums pretty much every year that I've been working at the company for the past 10 years at Oshkosh, and I go fly around to local chapters and do that. I will put this out there that if you are close to the Seattle area and you need somebody to come and talk to your chapter, give Dynon a call. We'll see what we can do to help you out with that. What is the quality of the documentation that is provided? I kind of give you some great examples here. Down here in the left-hand corner is what we call product data sheet. It gives you all the information you need to know about the HDX 800. And we do this for every component that goes within the system. Here we're giving you a cutout that goes in the panel. We're telling you the width and the height of the product. And we're also giving you the depth. We also include weights and current draws for stuff like this, for equipment that has electrical current draws. In the center here, I cut out a page of our installation guide for an RV7 or an 8 or a 10 servo installation. One of the things that we try and do is make it very clear what comes in the kit. We do that by highlighting in a different color what is provided by Dynon in that kit. And this is only one of several CAD generated illustrations that we put into our installation manuals. And I can say that we recently have hired an illustrator that has just taken this to a whole new level. This one here done by myself is pretty good, but our illustrator just puts me to shame with what he can do and his capabilities. The one on the right is just another example of a Sonix installation kit that I designed early on in my tenure at Dynon. I had a Sonix, so I said, hey, let's do a Sonix installation kit. So there you go, some good communication by Dynon, and you will continue to see that grow in both quality and quantity in the near future. System components. My comment here is that the amount of system components can be overwhelming. What I have here is just a basic two display system for a Dynon. And you can see all the components that can be attached to a 2-screen system. You could have dual GPSs, an Ethernet, control knob, all this kind of stuff. And it continues to grow when you add things like fuel flow sensors, engine oil temperature sensors, amp shunts for current flow, pitot, AOA attack, and pressure sensors along with manifold pressure sensors. The system starts to grow and grow and grow. But I don't want to scare you away with that, because glass systems, they can require more components because they do more, but they're also more expandable and flexible with that kind of stuff. As you allow a system like basically a computer into your cockpit, you notice that it has that flexibility where you can keep it simple or expand it as you grow. And you'll hear me over and over again talk about the expandability of a glass cockpit and the system that goes along with that. If desired, they can be very simple. And what do I mean by simple? Well, a simple EFIS can be as little as a display panel, an ADA HARS, an OAT sensor, and a GPS receiver. That is all you need for your basic 6-pack using a Skyview system. So it can be very simple along those lines, as you can see with this.
I'll add just one quick thing
Sure.
to what David said about the components. We now have, so he showed you a kind of a logical interconnect diagram there that showed things that are connected via Skyview network and things that are connected to other systems or via serial connections. We now have harnesses to cover almost all of those interconnects, and things like all of the dark blue, the Skyview network. It's literally just plug and play. And other harnesses have color-coded wires that match the diagrams in our manuals. So we've made it as easy as possible there.
Great, yeah, great point, Mike. We've worked really hard at getting the system as simple to install as possible. So we've got a highly capable EFIS system, and it can be simple, but you can also start adding complexity to that. But we like to call it like highly capable, because we've taken that complexity and made it as simple to install as possible. I also want to kind of point out here some of the different components that you can start adding and expand in that system. Second ADA HARS, transponder, ADSB transmitter, ADSB receiver, an IFR GPS navigator, backup batteries for each screen, COM1, COM2, an intercom, engine monitor module, manifold pressure, all these things that keep going on. You can see it. I don't have a complete list here, and yet you can see how overwhelming all these different components and different features that can add it to a glass panel system. And I put this up here to, again, show you the expandability of your system. You can start off basic and just keep expanding as time goes on. Okay, before we move on, any questions so far?
So if anybody has a question that they'd like to ask, you can raise your hand. And again, for now, keep the questions on the topic so far. It looks like nobody's raising their hand so far, so I think we will move on. Let me see if there's anything in it.
Don't see anyone flailing their hands wildly trying to get our attention in the videos. So I don't. Yeah. I think you've been comprehensive so far.
Yeah.
All right. Great.
There's one question that was sent to me, and it says and the question is, do the displays contain an ADAHARS or are they separate LRUs? Yeah, they are. It's a separate module. There you can equip with one or more ADAHARS, and there's also an optional. There's a magnetometer in the ADAHARS. There's also an optional remote magnetometer if you want to get that away from the other sensors in the ADAHARS.
All right, let's move on. Okay, we're going to start getting into some of the fundamentals of installing this equipment. And before you even start installing, I would really advise you to start acquiring the information. Dynon has what we call a panel planner, both Dynon and AFS. What is that panel planner? Well, if you look down here, you can see what somebody has done is they've taken a very basic panel out of paper, and our panel planners are one-to-one cutouts that you can cut out and mess around with on your actual panel or something similar to this. If typically at the show, I would have them to hand out to you, but since we don't have, we can't give you that right here over the internet, we can't download that from our website. If you want the actual physical catalog, send us an email requesting it, and we can mail those out to you. It helps you design your layout. When you do your layout, play with it, sleep on it, ask friends about it, find other examples. Don't just jump into it last minute. You're going to find that you're going to want to lay things out. You go see somebody else's panel, and you're going to find a really slick idea that they came up with that maybe you want to copy. So don't just jump into it, play with it, and come out with different examples. And if you do end up having somebody else do it for you, make sure that you are communicating to them that there might be some changes coming on before you tell them to go ahead and cut metal. So how can you do that layout? Well, there's software. There's things like Panel Planner that is available for a small fee, XPanel, and even SolidWorks. SolidWorks is available with your EAA membership for free. Dynon does provide DXF files and CAD files that allow you to bring even our components into the SolidWorks and play around with them. We also provide cutouts, everything that is completely transferable to a shop that would cut out your panel for you. Acquire the panel cutout drawing from the manufacturers. Again, I'm kind of highlighting a spec sheet here that we have, that we provide, all downloadable off of our website. You can cut your own panel, or better yet, you can have somebody cut it for you. There's a couple companies right here that I point out: Aircraft Specialty that will cut panels, Aircraft Panel that will cut panels, and they are very familiar with our stuff. They know how to cut out our equipment and how to mount the anchor nuts, etc., to get you a great and be very successful panel. Now, of course, there's always a ultimate option here, which is to go to Advanced Panel. Advanced is a sister company of Dynon, and we're very proud of what they're able to do. And I'll give you an example here in a second of what they're capable of doing. But this is one of those things where if you are very susceptible and very scared, for lack of a better word there, of wiring your own panel. I always joke with the president of the company, Robert. I said the scariest part of a builder isn't the first flight. The scariest part of a builder is turning on the panel for the first time and praying you don't see that magic smoke come out. Magic smoke is very expensive, and I'm sure that there's a few people in the crowd that have experienced that. Given that inability, go ahead and talk to Advanced Flight. They'll give you a quote for free. They're very friendly, and they've done this time and time again. They know what they're doing. As an example, here's one of the systems that Advanced has put together. Shows all of the harnesses along with their ACM module, which is an absolute wonderful module. It's basically an electronic circuit breaker along combined with a box that magically connects all of the components so that you don't have to do the wiring yourself. It does it all internally. You just simply connect the harnesses to that box and voila, you're done and moving on. And then you get yourself a nice, beautiful panel sent to you like this from Advanced Flight. Absolutely gorgeous layout, very well laid out and very well thought out.
If you do want to learn, sorry, David. If you do want to learn more about the advanced panel from Advanced Flight Systems, we have a forum on that tomorrow at 4 o'clock.
Great. One of the things I try and educate people on is panel layout. And I see it time and time again where not a lot of thought goes into where the components should be placed. And you kind of get this busy panel. The FAA has gone out and created an advisory circular 23.131-1C. And basically what this does is it goes through in detail, think government document, of how to lay out a panel. They talk about field of view for the pilot, and it's all based off of an average panel distance to the pilot's eye. They deem that to be around 30 inches. And at 30 inches, you want this 15 degrees of sweep from the left to the right, 30 degrees from the top to the bottom. And it really translates into about 8 inches either side of the direct center line of the field of view. That is the optimal area without having that. Is that for primary equipment, primary instruments, you should not have to turn your head and still have everything in viewable sight. This isn't a requirement for experimental, but it is a requirement for certified aircraft. And that's what you're seeing here. This is a panel that I laid out in our Bonanza, and you can see how the primary instruments are laid out right along the center line of the pilot. The yoke is swung over to the side, just to give you an example. Our backup instrument is still within that center line and that 30 degrees. All of the autopilot control panel, the comm control panel, and the knob control panel are all within that 8 inches side to side of the pilots. This was very well thought out and you know, it was, what's the word I'm looking for? It was reviewed by the FAA very critically when we did the layout of this for our STC.
Hey, David, one question we get in the sales office pretty often, more so for the certified side of the house, but is placement requirements for the D10A. You want to talk on that for just a second?
Sure, the D10A is considered a backup instrument, and again, it's not required in experimental. Originally, the D10A was laid out over on this side panel, and that was not acceptable to the FAA, so we came up with this location. The D10A has a very small screen compared to the other screens that we have, so we try and keep that as close to the pilot as possible. It is a backup, so not as critical, but you definitely want to have that viewable by the pilot without having to do any side-to-side movement of the pilot in the cockpit. A slight turn of the head is not bad, but again, eye movement is what the FAA finds critical in that. Here's an example of an advanced flight system installation. I show this to show you the depth of some of the components that you have to keep in mind, that there is depth to all your components. And even though the component might be 2 or 3 inches in depth, you still have harnesses to deal with. So keep that in mind when you're laying things out. You have a harness that, even though it might be 2 inches long for the housing, the harness itself comes out and has to make a radius turn. So very critical that you take that into consideration where you're laying components out even behind the panel on your sub panel. I put this up here as just sort of a nice example of a Zenith 650 panel. Very clean, very well laid out, everything well within reach of the pilot and even the co-pilot in this. Here's an example of a Sonix panel. How do I know that? Well, this was my Sonix that I built. People say that you can't get 2 screens in a Sonix panel. I did it, 2 7-inch screens, not the 10-inch. Don't ever tell anybody I said you could put 2 10-inch screens in a Sonix panel. Again, everything in the panel is thought out as far as accessibility to the pilot. Everything that is most critical to the pilot, like the radio, is very accessible to the pilot. Okay, any questions so far that we have to answer, Mike?
I think we are okay on the chat. If anybody has a question,
there's one hand raised here from Chesapeake. 1 second, let's get him unmuted.
Hi guys. On your Bonanza example of the screen installations, I know on Bonanza's the ones where you can switch the yoke back and forth between pilot and co-pilot. Have you ever run into any issues where the FAA has a problem with like that yoke obstructing maybe that backup screen or something like that? Or have you ever run into any issues with like something obstructing one of the screens and then the FAA being like, that's not cool?
Good question. And the answer to that is when the yoke is in flight, it is pulled back significantly from that location, which allows very good viewability of that D10A. I'll back up here a little bit to kind of show you that. If you imagine this yoke swung over here and pulled back about 10 inches, the pilot eye is up well above this, and it gives you a viewable of the screen on the D10A. We had to move this up as high as we could without the kicked out bezel of the HDX obstructing it. But you can move it up as high as you can to get that viewability. You also don't want to obstruct the switches down below on the lower bezel. Did I answer your question?
Yes, thank you.
And yeah, and of course, in a certified installation, you know, there is, you know, it's always a good idea to make sure you're complying with, you know, things like advisory circulars, because although that's not law, it's, you know, basically is policy and represents the FAA's opinion, you know, collectively on things. And as, you know, David was saying, the main thing you're trying to do is you want to have, you know, visibility. You know, as a pilot, you know, you don't want to be, you know, have it way over on the right. You don't want to be craning your neck when let's say everything else has failed and you're on like one backup instrument and it's still super capable, but, you know, you don't want to, you want to have that thing, you know, near front and center as possible.
One resource we've kind of put together too is our certified panel photo gallery, which you can see the D10A in a number of different locations, sometimes below, sometimes to the left, sometimes to the right, sometimes up high. There's different thoughts and schools of thoughts, I should say, on what the ideal placement is, but you have options.
Okay.
I think there's one other hand raised. Danny. Oop, unmute.
Hey there. So a question I have is recently, within the last 10 years, there's been some STCs issued for avionics that are not TSO'd. And I'm wondering, in my mind, that's put a little bit of a gray area on when you need a TSO and when you don't. And so I'm wondering if you could speak a little bit to that. When do you need instruments that are TSO'd if it's going into a certified airplane versus non-TSO'd?
Yeah, that's a good question. So fundamentally, you need approvals for design, manufacture, and installation, right? Those are kind of like that's the triangle of what it takes to have a product that is okay, thumbs up to be installed into a type certificated airplane. TSO is kind of the way that, because what TSO is a document that says, here's a standard, and if you meet all of these things, then and you prove it, you get this stamp, or you can claim TSO, and then you're good to go. But that's not the only way. And so one of the things that we pioneered actually with EAA a few years ago with the EFIS D10A, and now with Skyview HDX, is coming up with ways that to satisfy all of the laws in perhaps a less burdensome way than the TSOs, which are kind of written in a one-size-fits-all sort of way. And ultimately, if you're holding, if you have available an STC, which says this thing can go in that airplane, that is all you need to know, right? Because it'll call out the thing, whether it's TSO'd or not. Our products are not TSO'd, but they do carry PMA, which is parts manufacturing authorization. That's the manufacturing piece. But ultimately, if you have that, something which, if you could hold up a STC that says, this product, and there's an associated list of things that we sell you under that STC, you're good to go. So that's what from the customer perspective, it's anything that's STC'd. The certification basis behind it, whether it's TSO or some other route that's acceptable to the FAA, is perhaps something that at the end customer level, you won't be as concerned about. But if you were asking a company, if somebody says, you can put this in your type certificated aircraft, you'd be like, can you show me the STC? And actually, you can look them up online. You can just Google Dynon in the FAA database. You can find the STC there as well. Good question, thanks.
One follow-up is that part of the purchase process is when you are placing your order, you'll fill out a form and provide specific information about you as the owner, the airplane's tail number, serial number, model, and the installer of record who's going to be putting it and signing off on the installation. And that comes to you in the form of a digital document, hereby granting you permission to use our STC for this application. So you get a digital document that is the legal basis that goes in the logbook as that part of that installation.
And from our perspective, like we will not sell you something that cannot be legally installed in your aircraft.
All right, can we move on?
Yep.
Okay, so now we're going to start getting into some of the meat of the stuff. We've talked about some of the pretty things, but now we're going to start talking about actual equipment. And the first thing we're going to talk about is what I call the most critical piece of equipment in our avionics system, which is the ADAHRS. And this is really the brains of the entire system. If you get this wrong, you're going to be very sorry. You're going to have a system that reacts, performs poorly. So we've tried to make that as simple to install and as flexible to install as possible. And I'll get into that a little bit during this part of the presentation. Some of the things you want to be very aware of when you're doing this installation is you want to make sure that you install it on a rigid surface. Vibration in this is very undesirable. We have an algorithm that can detect what we have determined to be known vibrations of a typical aircraft, and we filter those out. But what I've actually seen people do is put this piece of equipment on top of rubber isolators, and they see a poor performance. And the reason for that is because we're expecting certain vibration with this, but you want it to be rigid. You don't want it to be on top of something rubberized. You want it to be a very rigid mounting on that. Hardware, do not put rubber washers on it. Make it sure it's rigid and is not swinging around in large isolation. Think of a waveform, and the larger the amplitude of that, the harder it is for us to detect what your aircraft is doing. Small amplitude, which is what typically you see in an airplane, we can filter that out and move on. As close to the center of gravity as practical, we give you this nice little chart here that says what you've got, the box you've got, which is 12 feet longitudinally and 6 feet laterally. Anything outside of that box there, you're going to start seeing significant performance degradation in your system. No closer than 24 inches to ferrous metal. Now, I will tell you that this does not apply if you're using a remote magnetometer, and I'll get into the remote magnetometer mounting in just a bit. There's two types of ferrous materials that we talk about in our system installation: static and dynamic. Static ferrous materials can somewhat be tolerated. What I mean by that is a bar, you know, a piece of steel, a ferrous material that does not move. Something like that, a bolt, that kind of things can be calibrated out when you do your magnetic compass calibration. But if it's moving, very difficult. Imagine a steel push rod or like a seatbelt buckle. I actually had a fellow Sonics builder who put his ADA-HARS right behind the baggage compartment, and it was working fine. And then one day he went flying and couldn't figure out why he was having such bad performance on his autopilot. When I talked to him, he had put his laptop in his baggage compartment, which was about 4 inches away from his ADA-HARS that he had put right underneath the baggage compartment. And that laptop completely messed up the magnetic compass and affected the performance of his autopilot. So be aware of that. Not only is it static ferrous metals, it's dynamic. And again, does not reply when you've got a remote magnetometer. We recommend 36 inches from any transmitting antennas. That can be a transponder or a comm antenna. Not so critical when it's just a receiving antenna. Stay away from electronic devices. It all depends on how much EMI that device radiates. We can't tell you that if it's not our stuff. So if it's something a different manufacturer makes, a computer fan, something along those lines, just stay away from it. Orientation is required on this and very critical, no matter whether you're using the magnetometer or not. The direction of flight has got to be with everything pointed in the correct direction. And I'll show you an example of that here in a minute. Basically, you got to think of the ports that are coming out the front going towards the front of the aircraft. Parallel with level flight. With level flight, what I mean by that is that if you have a tail dragger and you to be level flight, even with a standard nose dragger, you've got to make sure that that is parallel with level flight. We say plus or minus 1 degree in the installation manual, and we'd really like to see you stick to that. So here's some examples of installations. Normally I would ask people to raise hands and tell me what they see, but I'll just talk through it. What we've got on the left-hand side here is an RV7 installation. I give A for the ability or, you know, the thought process that the guy went through to do this installation. But the problem is he's got two really long pieces of sheet metal here holding up his ADA-HARS. What he's going to see in flight is that this is going to move back and forth tremendously. And I'm exaggerating for a point, but that's not what we want to see in installation, okay? What we want to see in an installation of the ADA-HARS is something much more along the line of what we have here, where we've got nice thick pieces of aluminum. We've got 3 of them coming down, nice rigid. He's kept the arm of this piece of aluminum nice and short so we don't get a lot of vibration back and forth. And this is a dual ADA-HARS installation. This is a very nice done installation. That's what we want to see an installation in. Okay, remote compass. So Dynon came out with a remote compass several years ago to really take care of you tube and fabric kind of guys that were seeing problems. And we came out, it's the same enclosure as we use for the ADA-HARS, but we put a pigtail on it. And a pigtail is what you see there. It's a length of wire. And we do that to keep the module, I said module, the connector away from the module, okay? So as with your 80A mount, keep away from ferrous materials. Again, if it moves, stay even further away from it. If it's static, we can somewhat calibrate that out, but again, stay away from it if you can. Doesn't have a specific location. In other words, you don't have to follow within that box like the 80A does. We see these installed way out in wingtips. There's no accelerometers in it, so doesn't matter whether it's going at a faster speed than the left-hand wing than it does in the right-hand wing. Does not matter what location you put it on the aircraft. But again, stay away from ferrous materials. Orientation, there is an orientation requirement. Typically, the pigtail has got to be facing the direction of flight. Pigtail should be at its extended length. That again, as I touched on, is to get that connector away from the magnetometer inside that box. Here's a great example of a nice installation. The builder has put it on a nice rigid mount here, and he's got the full extension of that pigtail going out, keeping that connector away from the box. Okay, any questions on the 80ARs or magnetometer installation?
I'll add just one thing on electronic devices and the magnetic sensors, whether you're using the ADAHRS or the magnetometer. Current carrying wires and devices generate electromagnetic fields. The more the power, the more the current, the higher that field. So for things, let's say like wires that are running to our GPS receiver antenna, they're very low current, very low power. And so those devices aren't going to affect, or those wires aren't going to dramatically affect the magnetic sensing performance. Now, on the other hand, the power carrying cables, which are going to your autopilot servos or the servos themselves, you're carrying amps, a few amps to each of those servos, and the wires that are going to those are it's also dynamic. Sometimes they're on, sometimes they're off. And so that would be an example of thing to stay feet away from.
Right, you have almost up to 5 amps going through those wires, so
exactly.
Stay from those kind of wires.
Any other questions on the topics we just covered? Otherwise, I think I don't see any hands, so I think we're good to move on.
Okay.
Oh, wait, one question from Scott. Just got it.
All right, Scott.
Looks like you're unmuted, but I don't know that your audio is working.
Scott's been chatting with us as well. If he's not able to get his audio working, I'm sure we can relay the question through chat.
Okay. We'll do that as that comes in. Why don't you go ahead and carry on, David.
Next thing we're going to talk about is the EMS module, the engine monitoring module. Again, severe vibration. Vibration does things to electronics that aren't good. So just try and keep things away from high vibration areas. Make it a nice rigid mount. Don't put it on a piece of sheet metal that's going to bounce back and forth. And I'll give you some examples here towards the end of this section. Avoid excessive heat, high temperatures. The reason for that is multiple things, but high heat can cause electronic components to drift, and it can give you inaccurate readings. You have something very hot, you've got sensors inside that box, they're going to drift slightly and give you different readings. It also can reduce the lifespan of electronic components. I have seen people mount EMS modules on the hot side of the firewall. Not recommended. They tell me, oh, it works just fine. I understand it works, but you're reducing the lifespan of that piece of equipment. And having an EMS module fail while you're in flight over the Rockies is not something that you want to encounter. So do yourself a favor, keep it on the cold side, keep the vibration low to it. And again, with almost every bit of electronics, keep it away from EMI, spark plug wires, wires with high current, magnetos. Further away from high energy EMI, the better off you're going to be. This has no specific orientation. You can mount it underneath a seat. mount it underneath the panel, right side up, upside down, whatever you want to do. No specific orientation whatsoever. I touch on this because we get this quite a bit when it comes to the thermocouples, and that is, can I cut the wire? Yes, you can cut the wire, but I suggest if you do cut the wire, make sure you're cutting the right end of the wire. I have had people cut the wrong end of the wire, so make sure you're not cutting the thermocouple end off. But I also suggest that you keep the wire lengths as reasonably as possible the same length. And the reason for that is possible troubleshooting future. And sometime in the future, you might have a cold cylinder. You might want to swap a thermocouple around to see if it's a thermocouple or what cylinder it is. This gives you that ability without having to add a completely different thermocouple in that. So if you can keep those lengths the same, the better off you're going to be. If you do need to extend the length of that wire, then I strongly suggest you contact Dynon. We have worked with people in the past to provide them either extra length in that harness or given them some sort of extension. We do ask that you keep, if you do have a junction on that wire, that you well insulate it and keep it away from any sort of heat source. You will get drift if that happens. And as I said, I can't preach this enough. Do not install it on the hot side of the firewall. People all the time tell me, I did it and it works great. Don't do it. You're going to regret it at the worst time in your flight. Okay, so here I've got a couple examples. Sonix builder decided to mount it right underneath this panel here. Not horrible, but not great. He's going to get a lot of vibration with this big, long, and extended piece of aluminum down here. Probably not going to do a lot of damage, but I can think of several different ways that would be a better mounting than where he's got it here. He's also going to have to deal with depth issues on other equipment. So, not a great installation, acceptable, but not a great installation. RV8 owner over here, I think this is an absolutely wonderful installation. He's got it up, tucked out of the way, yet he's given himself easy access to his firewall through this port down here. So keep that in mind. You've got a really big bundle of wire coming through the firewall, which is all of your thermocouples, your EGT, your CHT sensors, along with your pressure sensors and your temp sensors on all your oil. So keep that in mind. You've got a fairly big, thick piece of wire, bundle wire coming through. You want to keep that as short a distance to the firewall as possible. Putting this module in the back end of the airplane, unless you've got a pusher, is probably not a great place for a location. Here's a couple other examples. I believe this is an RV7 where the installer has put it right here. Again, a nice, easy path through the firewall out into the engine bay area. No fire sleeve here, but that's just my tech counselor talking. Over here on this side, we've got a module mounted in an RV14 right next to the ACM module. Again, not a bad location, but he now has to run wires through this bulkhead and a bulkhead back here to get to the firewall. I would strongly suggest moving this forward more and getting this a little bit closer to the engine firewall. Much easier to run this cable to the ACM module than it is to run all of this stuff to the back firewall or the forward firewall. Not bad, just not a great installation. Keep that in mind when you're doing yours. Okay, any questions on the EMS module? We're hitting pretty good on time so far, Mike, so I'm going to keep going forward unless we hear something else. Kyle, did you get any questions? We're good?
I don't. So far, everybody we've been able to handle in chat. I think Scott got his question answered as well, so I'd say keep going, and we'll let you know if something comes up.
Okay. Another installation fundamental, the GPS receiver. This is probably the second most controversial installation that we get, the GPS module receiver. I have horror stories of people actually putting this on the bottom of the aircraft. Please not put it on the bottom of the aircraft. Again, a rigid surface. In fact, I would recommend a doubler on this, even though it's a small piece of equipment. Definitely put a doubler on the backside because most people mount it like you see here in the picture on the turtle deck on top of the skin, you definitely want to double up that skin at that location. 36 inches from any transmitting antenna, I will say not such a big deal with an ELT antenna. Why? Well, if your ELT antenna is transmitting, you've got other problems. You don't really need to know your GPS position. So kind of a give me on that one. If you want to put it fairly close to your EL antenna, you could probably get away with that one. Orientation, skyward. Again, I've had absolutely horror stories where people tell me that they mounted it on the bottom side. I actually had a amphibian aircraft that I went out and did an inspection on, and he had put it on the bottom side of the wing. He thought it was all right because it was above his head, but not where you want to see it. It's got to be pointing skyward.
Mike, a question that you've been posed, if you're going to touch on this anyway, but that comes up often is where are places people can hide it? What kind of cowl materials can they put it under, or should they avoid?
Yeah, so any kind of metal, even carbon, is not a good place to put over the top of this. You can get away with it with fiberglass, with the exception that most people paint fiberglass, and if you paint it with a metallic-based type of paint, then you're going to really degrade that performance of that GPS receiver. So the best thing, it's designed to be outside. You can put it outside. If you do have a glass or plastic airplane, as they call them, you could probably get away with it underneath the fiberglass. Again, I would just caution you on what kind of paint you put over the top of it. We do say in our installation manual that you should not paint this at all. We have a very robust paint that we have on top of this module that comes from the factory. It is not a metallic paint, so we know that it is not affecting the performance of that GPS receiver. You want a 360-degree unobstructed view to the horizon with this. I'm going to give you some examples here in a minute of some bad things that I see people do with installation. But just imagine yourself, if you're sitting on top of that GPS receiver, you should be able to see, turn yourself around 360 degrees and see the horizon without any significant obstruction. Now, obviously, a vertical stab is an obstruction, but it's such a small obstruction in that vertical position, you're not going to see any degradation of performance with that. Not something to be concerned about. One of the things I do like to talk about is how the signal strength can be affected. And what I've got here is a picture of what you can see in Skyview that'll show you the signal strength of all the GPS receivers. And you can see in this display here that most of them are pretty strong. If you're not seeing this with your installation, you have got a bad installation. This is something that we strongly recommend you do before first flight. Go out, push the airplane out away from hangars, let it acquire all the GPS signals that it can from those satellites. Take a look at this page and confirm that you're getting good signal strength. The last two that are white there, those are the WAAS integrity type of GPS satellites. Those are critical to the entire system, so make sure that you're getting that also. One of the things I touch on is the high integrity of the 2020 ADS compliant GPS receiver. That is really finicky about the satellites that it will receive. Why? Well, the FAA has mandated that. They say that you can only receive signals from certain satellites. With our 250 GPS receiver, we receive signals from satellites that have been up there, what we would call legacy satellites, but we don't care with the 250. We're just looking for a signal that we can give you a position source to. Because of that, I do recommend that you install a 250, or if you have a 250 installed and you're upgrading to the 2020, go ahead and keep that 250 in your system. You'll find out that it's a great backup. It really complements the system well if you don't have a second GPS receiver. Stay away from electronic devices. This includes everything from transmitting antennas, any sort of EMI radiation, servo, anything like that that's going to do it. Even another GPS receiver. And the reason why I say that is because our receiver in particular is not only an antenna, but it has electronics inside of it. It does emit a small amount of EMI, and if you're butted right up next to each other or stacked on top, you're going to see a little bit of degradation in performance. The nice thing about our receiver is it's a simple 4-wire connection. It's not a B and C connector like you see on a lot of other receivers. I say receiver, what I really should say is antennas, because they are nothing but an antenna. Ours is, again, a complete system within itself. Therefore, it's a 4-wire connection. One of the things that you will end up doing with the 2020 ADS-B test is what they call the PAPR test. And you go up and you fly a certain pattern, a figure 8, and you'll get a report back from the FAA. And even though you get a report back that says you pass with your GPS, with your ADS-B compliant system, the one thing that I will tell you is that if you have an installation that might pass the PAPR, it might not pass the I'm flying down a valley trying to scud run through the valley test, and all of a sudden I lose my GPS performance. So keep that in mind when you're doing an installation. You want that 360 unobstructed view. Here I give you a couple examples. Common installations that I see. A 1X, it's very common for people to install it right back there. Why? They don't want to put it on the turtle deck. But as you can see, what you've got is a nice big wall of aluminum behind there. That's an obstruction. Yes, the GPS will get a reception. Yes, you will get your synthetic vision. You'll get a position location. But you're cutting out your performance by having this big wall of aluminum behind it. We also see this common on RV-12 installations. Why? Well, Vans actually had this as an installation. They have since moved things around a bit, and because the fiberglass cowling goes right over the top of this, you see this kind of installation all the time. I highly recommend this is not a good installation. Do something different. Is it really worth losing your GPS location so that so that you don't have an antenna sticking on the outside of your airplane? Please don't do this installation. I beg of you. This is the kind of installation where you're flying down a valley, you're scud running, and all of a sudden you've got mountains obscuring your satellite reception on both sides. You've got your firewall obscuring any sort of reception behind you. You're going to lose satellite reception. Just don't do it. Think about that. Here's some good installations. Back of a turtle deck. In this location, the canopy will slide back and go right over the top of that. No problem. So it's a good installation. And you see here on an RV-10, same kind of a thing where an installation on the back of that aircraft is a great installation. You're not going to get in flight, you're going to get plenty of satellite reception. Okay, any questions on that GPS installation? Anything to add to that, Mike?
I think you covered that pretty well. I would, the only thing I would add to on the SV GPS in 2020 in particular, because it is used for performance credit with the FAA and ADS-B out, you really don't want to paint that. You really want to leave that as is. You know, if you,
David, there were a couple questions in the chat about proximity to other GPS receivers and ground planes. Couple questions along those lines. Are there any big topic items you want to share on that?
Yeah, again, I would say keep away from other GPS receivers. I've seen with ours, I would say 6 inches away from ours is a good distance. You just don't want them butted right up next to each other. A ground plane, not completely required with our installation. As a matter of fact, we have an insulator on the bottom of ours to keep you away from that. So no ground plane is required in our installation.
one thing that's different with our GPS, you know, antenna, even though it looks like an antenna, it actually has the receiver built in. So there have been examples of, so most other products, the antenna is just the antenna and it runs coax back to the receiver, which is often in the device, but ours is kind of a self-contained thing, just like the GPS in your phone or in a fitness watch or something like that. So it really is a self-contained thing. So then if you're co-locating a 2020 and a 250, those are our two GPSs. They don't need to be that far ahead from each other. I don't have the manual up in front of me, but I don't know that there's a strong distance requirement. Like it's not feet, that's for sure. But still, if you put them right up next to each other, you're going to get some blanking between them. But there shouldn't be any interference in the conventional way because, again, the antenna is feeding that device right there. It's not going through coax, and it's not really an RF device in that strong a way.
And with it being, just a wired connection, not a coax, the question actually just came up about, do I need one GPS per display? And so since it's a wired connection, you simply can share one GPS with as many Skyview displays as are in the aircraft. You could add multiple for redundancy if you wanted to, but one will get you done.
You have to splice those wires in on each main harness, but yes, you can use one GPS for multiple displays.
And then, going back to mission and redundancy, especially with IFR, the analogy I'll often use with customers is you want to be able to take a hammer to any product or any module or component in the system, and that not turn a fun day into a bad day. So if you had just one GPS source that's feeding everything, that's not a great thing. Now, normally, if you're doing let's say an IFR panel, you'll have our SVGPS 2020, which is your ADS-B out source and your high integrity position source. You might pair that with Navidyne or Garmin IFR Navigator. That's your second GPS source that can feed Skyview as well. So then you take a hammer to ours and you still got that third party source. You take a hammer to the Garmin, right, and you still have Skyviews.
Yeah, if you're flying IFR, be very careful and be very studious about how you're mounting these things. Yeah. I preach this. I know I'm probably preaching a little bit too much about this, but yeah, it'll work on a great blue sunny day and you're flying at 5,000 feet in a prairie. But it's that day that you're trying to scud run and you've got mountains around you or some obstruction, that's when it's going to fail. And that's when you don't fail.
And one of the things, there's been a few questions around the notion of can Skyview, is it IFR, is the GPS IFR, can you fly approaches with our high integrity GPS? And there's a question that's currently going about WAAS. So think of it this way, it's the navigator, it's not necessarily the GPS position, it's the navigator as a whole that's certified for IFR guidance. You have a WAAS GPS in your cell phone these days. You can't fly an IFR approach with it. Same thing, the SVGPS 250 and the 2020 are both WAAS enabled GPS. That just means it uses the WAAS correction satellites to be, very high, not necessarily integrity, but very high accuracy. And so Skyview by itself is a complete IFR suite of instrumentation, the attitude, all of that, fully capable into going with IFR. The one piece that we don't have, let's say, certified or approved is the navigation portion of the system for IFR. So if you're going to fly IFR and you want to fly GPS approaches or en route GPS, you'll pair our panel with one of those approved IFR navigators like the Navidyne IFD 440, 540, or the devices from Garmin.
All right, moving on. I kind of blow through this stuff. We're a little bit behind on time, but this is the easy stuff. Transponder, avoid severe vibration, just like almost everything else, excessive heat. It does require an RG400 coax cable routing. When you're routing that wire, try and avoid routing that coax cable with other wires, especially things that are high emitters. Keep the radius, this is a AC 4313 requirement, keep the radius of that bend less than 10 times the diameter of that coax, okay? Another thing is, even when you're routing that wire, don't bend it or kink that wire. And the reasoning for that is most of those RG400s have got a mesh, an internal mesh in there for the shielding as provided in the cable itself. And when you kink it, that mesh opens up and it cannot go back to the same as it was before. And you're going to see a degradation in performance because of that. So do not kink. Do not make excessive bends when you're routing that wire. Keep those coax cable runs to a minimum. We have some information on our installation manual that kind of goes more in detail as to what that is. But if you can mount the transponder module itself as close to the antenna as you can, you're going to be better off. It does have a TNC connector at the module. So if you go from TNC, and typically most of the transponder antennas have got a BNC. I put this in here because we get this all the time where people call up and say, hey, can you sell, or do you have something that will convert a TNC to a BNC? Those are readily available. They're very common. They're actually pretty affordable too. But keep in mind, it is a TNC connector. I'll get a little geeky nerdy on you here. The difference between T and C. T stands for threaded. B stands for bayonet. The further away from high energy EMI, the better. No servos, no motors, no strobes. No specific orientation. You can mount this anywhere in any orientation you want. It is antenna specific. There is a specific antenna required for transponders, and we do sell one, and it's a fairly simple installation. Nothing much to worry about installing it. And here's a few examples of locations for the actual transponder module. The one on the left, no, don't do that. You're right below a servo. You're just asking for trouble, okay? Keep away from that kind of an installation. The one on the right, perfectly acceptable. The installation is far enough away from high emitters, the servo in the background there, so it shouldn't be a problem. Nice cable routing, nothing that's a high output cable that's routing with that, should be good to go. Transponder antennas, a couple examples of what a transponder antennas look like. Pretty simple installation, but it's got a BNC connector on it. Keep it away from other high energy emitters, servos, motors, strobes. It's a coax cable run. Keep that coax cable run to a minimum, as I mentioned before. It doesn't have a specific orientation, meaning rotationally, but it does have to be located on the bottom of the aircraft. And if you do put that on the skin, again, a doubler. Anytime you mount an antenna to nothing but bare skin, you want a doubler on there. Yes, it's short. It doesn't have a lot of drag on it, but today it looks great. 10 years from now, without a doubler on there, you're asking for trouble. There is antenna separation. We give you all this information in our installation manual, but I'll kind of quickly go over it here. 3 feet from a comm antenna, 6 feet from any sort of DME equipment transmitting antenna. Okay, anything that's an emitter, you want to keep away from this antenna. This is a high emitter itself. This is probably one of the most high emitters on your aircraft as far as constant emitting next to the comm. It is required a ground plane for this antenna. And I'll give you an example of some good ground planing here. The one on the left, tube and fabric aircraft. It's got a nice ground plane there for his transponder antenna. One on the right, good installation. He's done a doubler on it. Even though he's on the skin, I guarantee you that the installer there is going to be much happier with that doubler than if he put no doubler there at all. And again, think time. It's not just today. It's 2 years, 3 years, 4 years down the road. You know, maybe that antenna has come in and out 3 or 4 times. You just want to make sure that you put a doubler on anything for structural integrity. Okay, I kind of went through that fast, but I want to make sure that we don't run over time here. Any questions on transponder installations?
There's a question on the chat, or I think on Facebook, which was any issue running the GPS 2020 wires through the loom with the other antenna wires, transponder, ADS-B, etc. And I think the answer to that is there should be no problem. Again, the GPS 2020, because it's a low current device, it is not a high powered device. It should not impart any interference on those other things.
Totally agree with that.
If it was another GPS thing where you're running coax, yeah, you got to be a little more careful about what you run it with. But yeah, ours it's just data wire, pretty robust RS-232, low current.
If it was a servo wire that Running back to your pitch servo, no.
Yeah.
Definitely don't want something like that.
Another thing I'll mention, you're talking about ground planes. One thing that people sometimes think is that your ground plane should be, say, like a nice perfect circle. It turns out ground planes work better when they're irregular.
Yep.
So a square is really good. You know, if you were just cut like a piece of foil or aluminum in a very random shape, that's going to be really good too. Better than doing it really good with, you know, if you would read somewhere like, well, it needs to be, you know, ideally a radius of whatever. So you think, well, radius, that means a circle. So I'm going to make a circle. That's actually not going to make yourself a great ground plane. I don't know all the reasons. I'm not an electrical engineer, but one of our electrical engineers gave me the whole background on it. Also, RF is voodoo magic, so people have just discovered things that work and don't work. One last question.
We've been very
here.
successful with this kind of a ground plane.
Yeah, square works good. Do you need the serial connection from a Garmin GTN 650? The IFR navigators are fundamentally ARINC devices, but we do use the serial into the ARINC module, not into Skyview directly, to complete the 3D GPS position fix. That includes things like altitude, or GPS altitude, and a couple other things that don't come over the ARINC. So you end up using a serial out from your navigator into our ARINC in. I don't think there's any hands raised, so.
Okay. Moving on.
Yep.
Moving on.
Okay. So now we've kind of gone over a basic installation of a system, and what I'm going to ask you to do in this section, I jokingly call it "hold my beer and watch this." Really, what you need to do before you fly. It's a collection of things that through years we've experienced installers, common mistakes installers do before they have that first flight. You're nervous enough on your first flight. I've done 2 of them now, and I can tell you from experience, even though as much planning as you do, you're going to find yourself wishing that you had done more. There's things that you might forget. So keep in mind that there's some basic things that you can do with your system before that first flight. You'll have plenty of other things to worry about. These are things that you can do before that first flight so that you know you're not going to have any issues in your first flight with your system. So pitot-static system. This is something we see a common issue with. There is something in our system called a zero pressure calibration. I recommend you do this before. We do a calibration at the factory, but just as a good measure, there's a zero pressure calibration you can do. Put it inside a hangar, not a lot of wind, put a sock over the pitot tube, put a very light cloth over the static pressure ports, and do this. You just don't want wind moving. You don't want it to be, you don't want that pressure to change radically while you're doing the calibration. This sets all of the modules to a known zero pressure calibration. That zero pressure is what affects a lot of your readouts in your system, like altitude and airspeed. So good thing to do this beforehand. Last thing you want to be doing is going down the runway on your first flight, look down at your airspeed and see it's reading 250 knots, and you know you haven't even left the ground yet. Bad time to be doing some debugging at that point. So verify that your reading is correct and at these different pressures. One of the things that I suggest people do is get a very large party balloon, something that isn't a high pressure, and go ahead and put that over your pitot tube and make sure it's reading something. Don't blow into it. Don't have your 12-year-old son blow into it. You're going to ruin things doing that, okay? You want clean air. You want something that doesn't have a lot of spit, saliva in it. So a good balloon over the top of that. And there's 2 ports on the bottom of that pitot tube that are drain ports. Make sure you go over the top of those 2 when you're doing this test. That can also help you with a little bit of a leak down test on your pitot-static system. You leave that balloon on there for an hour or so and see how much deflated. There is an AC, the FAA has an AC, an advisory circular on what those are. I don't need to go into that kind of detail with this presentation. GPS signal is sufficient. I kind of touched on this already. Again, you don't want to be taking off on your first flight and notice that you're not getting a GPS signal. Push it outside, get away from buildings, make sure that you're receiving all the signals that you're supposed to be receiving with that satellite. Make sure that on your system, you can select the different GPSs if you have more than one GPS signal coming into your system. I had a situation where somebody thought they were getting GPS signal from ours. They were getting it from another system, and the virtual synthetic vision was very jerky, and it bothered them during their first flight. Come to find out that they were actually hooked up to another GPS receiver that didn't run at the speed that ours does, and that's why they were getting that jerky hesitation on their synthetic vision. So make sure that you've got that GPS signal, make sure that you're receiving the right one. Oh, and the other thing is, we get calls where people say, hey, I'm on the ground and it's jerking back and forth and it doesn't give me the direction. Well, GPS doesn't know what your direction is unless you're moving. Compass calibration. Do this in a certified location if possible. If your airport doesn't have it, go out, go someplace that's away from buildings. We actually had somebody that could not get a good compass calibration. Why? There was rebar in the runway messing up the calibration. So keep that in mind. Make sure you're going to some place where there's not a lot of magnetic deviation. You can use a wet compass to verify that before you do it. There is a calibration wizard that Dynon has in its system that will walk you through the calibration of your compass. Do this before your flight. There's also one that you can do in flight afterwards. As a matter of fact, I'm told that we require you to do both one on the ground and in the air. But don't do the one in the air on your first flight, please. It's not that critical. Once you get it done properly on the ground, you should have plenty of direction for your first flight. Nobody's flying IFR on their first flight. Just wait until you're comfortable with the plane. Make sure that you're flying in a safe location at a safe altitude to do the compass calibration in the air. Radio check 5x5, clarity and strength. Always critical to make sure that you can hear yourself, that you receive well, that you're transmitting well. Make sure that you've gone over with your crew on your first flight about the clarity and strength of your radio. Transponder, this is always a contentious thing where people say, hey, do I have to get the certification on your transponder before my first flight? I've asked FAA and I've gotten different answers every time. Okay, everything from you're the manufacturer, you can certify it, to not required because it's a first installation, to yes, you have to do it. If you don't have the ability to do it at your airport, I suggest that you arrange to do that at an airport that has that. I doubt you're going to see a ticket show up in the mail because you haven't done it. Or best of all, just avoid any airspace that requires that transponder to be working until you can get that certification done. Okay. What I'm basically trying to tell you is don't sweat it too much, but it's a good thing to do before your first flight so that you don't have to worry about it during that first flight. You know, again, reduce that workload on your first flight, even during your testing. EGT and CHT sensors, are they correctly located? We see this a lot where somebody has accidentally swapped cylinder 1 and 2. They go out, they do a run up, and cylinder 2 shows hot, and they can't figure out why it's running hot. Well, because they accidentally swapped the EGT or the CHT sensor. There's a simple trick that you can use to make sure that your sensors are correctly connected to your system. Get out a hair dryer, a hot gun, a heat gun, blow on that sensor, see what rises on the screen. Go on cylinder 1. If cylinder 1 shows a rise on your screen, you're good to go. Give you a couple tools for success here. You don't need to go out and buy a $600 D-sub pin crimper. Everything that we ship you can easily be done with a $40 D-sub pin crimper that you can get on Amazon or Allied Electronics. Make sure you adjust it correctly. There's instructions on how to do that. If you have a problem, give us a call. We'll tell you how to do it. For the few crimps that you have to perform installing our system, don't go out and spend the $300 to $600 that you need. This crimper right here will do it just fine. Get an EA membership if you don't already have it. My gosh, you're flying experimental. Get an EA membership. It gets you SolidWorks. It gets you access to a tech counselor. Guys like me that can come over and answer questions before you do that first flight, before you close up that wing, before you turn on the power to the panel and see the magic smoke come out. Nut plates, get a variety of them. On all of our technical data sheets that we have, we tell you the nut plate that you need and the quantity that you need. If you get that data sheet downloaded, you can find out how many you need and what you need. As a matter of fact, I even give you the hole size you have to drill for that nut plate or anchor nut, whatever you want to call it. Installation manuals. Download all of those from our website. Any installation manual that we have or any of our experimental stuff can be downloaded for free from the Dynon website. Go there, download them. We update them quite often, so go ahead and check up on that often. Make sure you do that before and after you do an installation. Definitely do it before you do a first flight. Go on our website and make sure that everything is up to date. That also includes software updates. Make sure that you've updated that software before you do that first flight. Okay, any questions before I go on? We got anything?
I don't currently have any active questions in either chat, but let's give a minute for anyone to raise their hand, perhaps, if there's some questions that have been waiting for a moment.
All right. I will move forward then. Missing in action. What I didn't talk about today. Well, I didn't talk about backup instruments, comm radios, nav radios, intercoms. That's a big topic. Audio panel, that's an even bigger topic. Anytime you get into audio, man, oh man, we could spend a whole day talking about that. GPS navigators, how to hook those up. We touched on that a little bit, but again, that's a big topic that probably would take an entire forum to talk about. ADSB in receiver, didn't talk about in, we talked about out. Breakers, fuses, trim switches, servos, and ELT, didn't talk about hooking that up. Comm antennas, didn't talk about that. Pitot tube, we touched on it a little bit, but we really didn't talk about the installation of that. Your OAT, outside air temperature sensor, that, didn't talk about that at all. Why? Well, because I want to go to Oshkosh 2021 and meet all you guys. And I want to be there in the forum tent. And as a matter of fact, if you really liked this forum, talk to Mike there. Send Mike a nice email. Tell him what a great guy I am. Tell him how badly you want to see me at Oshkosh 2021 so they buy my plane ticket out there. Or better yet, pay the fuel for my RV-7 that'll be flying by then. Did I make that clear, guys? Send emails to Mike.
and apparently David takes tips.
Again, mike.schofield@dynon.com. Anyway, guys.
Wait, do we not all take tips?
Here's the one slide I talked about that's got a lot of information resources on it. This is a lot more information than I could possibly touch on in this forum. Tech support, Dynon YouTube channel. We keep adding more and more content to that. There's some how-to videos. You'll see my ugly face on those. Mike even came up with some great meditation videos that are just a crack up to watch if you want to watch that. Advanced Flight System, Rod Hickman, he's the president of the company. He's very accessible, although a little bit less so these days. He's pretty busy. But Rob's a great guy. If you haven't talked to him, he's probably one of the most accessible and knowledgeable people I know about avionics in the industry. There's online forums like we've got going right now. There's the newsletter. If you haven't signed up for the Dynon newsletter, do it today. You get a lot of good information. You get notifications on products that are coming out before anybody else. If not minutes, maybe days before that happens. social media, Dynon AFS, we're both very active on social media these days, Facebook, Instagram, and even Twitter. I talked about downloads, manuals, free to you, product data sheets, free to you, schematics. We've done a lot of schematics, added a lot of schematics there. You can pretty much wire your entire airplane using schematics that Dynon has. And I strongly recommend you take those schematics, print them out, put them in your binder with all the other information that you have or you should have on your airplane project. Keep a binder full of information. I'm on my second one now with my RV7 project. If you ever sell that plane, it's a great thing to hand to the new owner. Here's everything that I did building that airplane. I also talked about software updates. Go download them, make sure you've got the latest and greatest software. The one thing I didn't talk about, because I don't like to talk about it, is a lot of our legacy products. Their software updates can be quite cumbersome at times, but we haven't had an update for those in quite some time. But they are still available for free on our website if you need to do that. I actually had a friend call up just 2 days ago who had a Dynon D10A. It had never been out of the box, and he was installing it in a project that he was just about ready to fly. He turned it on and it was reading 21,000 feet. It had been dropped a couple times, he admitted finally. It actually been through a flood. He didn't think it was too badly damaged, but I had him send it into the office just to make sure everything was going right. And we would do that software update for him for free if he sent it into the office. All right, there's your information resources. Again, if you need to get a hold of me, send an email to support@dynonavionics.com. Put attention David Weber in the subject line. If it makes it through the high filtration process of our support team, it'll get to me. I usually get 2 or 3 emails a week from our guys in tech support, mostly on Sonics. I imagine now that the word's out, I've got an RV7 project going. Probably see some RV7 stuff coming my way too.
You're my go-to forward guy from the sales box now.
Okay, planning for success. This is what we talked about before you buy. We talked about the system components. We talked about installation fundamentals for the panel, 88 HARS, remote compass, the EMS module, the GPS receiver. Talked about hold my beer, watch this, basically first flight stuff. Give you some tools for success. We talked about what I didn't talk about. And we also talked about some information resources. Thank you guys. Thanks for putting up with this. We're opening it up to some more questions. I'm going to put the screen back to Mike Schofield here. Again, mike.schofield@dynonavionics. How wonderful I was and how much you want to see me at Oshkosh in 2021. All right? Let's see if I can't give the screen back to Mike.
Yes, you need to stop sharing. As you know, you're basically signed up for eternal Oshkosh duty, so you don't need to do any selling of that. So we are going to open it up for questions in just a second. But for those of you, the 56 of you that have stuck around, and there's probably a couple dozen on Facebook Live, we're going to do another giveaway. This time it's going to be for a voucher towards Dynon products, $100 redeemable directly through us. It's kind of like a gift card. And so same rules as before. Starting now, a number between 1 and 100, throw it in the chat, either here in Zoom or on the Facebook Live feed. And in just a minute, we'll roll the numbers. David, one question that came up earlier that we'll start with once we get done with this was from RV12 Garage. I think that's his real name to us. Walk us through your thought process in laying out your new RV7 panel. You spent more than 10 years gaining knowledge, interested in your thoughts as a user. So think about that as we wind up this little giveaway here. And we've given everybody enough time to throw in their numbers. Let's see, the last number here is a couple more coming through.
Facebook got some numbers rolling in as well. There's participants. We're ready to party.
Okay.
We've got a couple on yes, we got some on Facebook.
Okay. I'm going to call it, let's see, M. Mueller on here. Okay, so let's see, I'm gonna share my screen. Here's the wheel O numbers. And let's see who is the winner. And again, the rules are closest without going over wins. And I didn't think of what would happen if there's more than one of you. 94 is the winner. All right, let's see. Do we have a
67 is the closest on Facebook.
94? Nice try, Danny.
Looks like we have an 88 in Zoom.
The closest is a 97. Well, so closest without going over. Price is Right rules here. If there's a so there's a 97. 97. And you can only win one prize per session, by the way.
I think 88 is the highest I see without going over. You see two 87s and an 88.
Oh yeah, I said 97. That is over.
Yeah.
I know numbers.
We can math today. I see John from the chat in Zoom looks like he has 88. That's the highest I see without breaking 94.
Now, is that the same John from earlier? You said you can't win twice.
Yeah, one
This is about to get real
interesting.
Can everybody just appreciate I've got a picture of David right behind me?
There you
The
go.
time continuum thing, man. It's crazy. Groundhog Day.
Well, if John is a previous winner, there are two 87s.
Okay.
Pete and Wayne.
All right, Jeff, if you want to message them and sort that out, we'll move on to questions while we do. And David, do you want to tackle that question that we asked about your panel?
So I would say I'm a little bit of an exception in the respect that my panel I laid out with the thought in mind that I would probably be doing some significant testing for Dynon going forward. So I tried to make things as accessible as possible. But if you go to the Advanced Flight and their RV7 panel that they produce, I'm pretty close to that. I've got dual screens, HDX, one left, one right. I had one mission in my panel layout that a lot of people don't have, and that is I wanted to be able to fly it from both left and right seat. So I wanted things accessible. As a result, I put the ignition down by the throttle knobs so that the person in the left seat can have access to left, right magnetos and turning them off and starting the engine. I do that because I do a lot of Young Eagle flights, and when I do Young Eagle flights, I like to put the kid in the left-hand seat to give them that experience of actually being a pilot. So that was a mission that I had in my panel layout doing that. I also wanted things very accessible on both left and right side. So I put all the modules, the control modules like the autopilot, the radio head, everything in the center of the panel so that it could be accessible by both left and right positions in the cockpit. The one thing that is not readily accessible on the right-hand seat is the D10A, which is on the far left-hand side of the panel. But I was willing to compromise on that considering it's a backup instrument. And I've got so much redundancy already in the aircraft with dual screens, backup batteries. I just didn't feel like it was that big of a deal. And if I am flying IFR, I'm not giving Young Eagle flight. So I'm probably sitting in the left-hand side. Does that answer the question?
I think so. There is a hand raise for Michelle. Let me unmute. We've clicked unmute.
One other thing I would touch on with that is I have really gotten into 3D printing lately. And I know I'm a little bit of a nerd. Mike and I are nerds at the office. We talk about rockets and a bunch of nerdy things all the time at the office. And I've really gotten into 3D printing to the point where I've made several parts that I've installed on my aircraft that are 3D printed. Everything from the NACA duct inlets to the autopilot disconnect button caps. Things like that have just really enhanced my cockpit layout installation. There's actually a Facebook page that people can subscribe to that's 3D printed aircraft parts. So if you're into Facebook and you want to know about 3D printing aircraft parts, go ahead and subscribe to that Facebook page, along with subscribing to Dynon if you haven't already. If there's interest in that, I'd be more than happy to share some of my designs on the Facebook page going forward from time to time. Oh, and my 3D printer is a Prusa, okay? Because I know that'll get asked.
All right, let's see. We had there was a person with their hand raised. I think it's Michelle. If you're still there, I don't see you anymore.
I clicked on mute, but I don't know that she ever it came unmuted. I see the hand is lowered now. So
okay. Let's see, a few other questions coming through in the chat. And again, raise your hand.
Avionics fan. There's a question that just came through. David, comments on that?
Highly recommend some sort of an exhaust fan. In the RB7, it's really easy to put it on top of the glare shield. Also doubles as a defogger on your windshield. But the Dynon system itself has got some absolutely huge heat sinks on the back side of it. Things that we did testing where the fans that are on the heat sinks really only have to kick in on an extreme temperature. But we did that for reasons. Imagine an aircraft sitting on a tarmac in Phoenix, Arizona, and within 30 minutes, it's up at altitude where it's 30 degrees below. So turning on the system, having those fans kick on with the heat sink really gets rid of that heat, gets that out of there. And the more you can dissipate that heat, the better off you are with electronics. But as far as going overkill on it, it doesn't have to be a big fan. A small computer fan, just something to get the air evacuating. I highly recommend you evacuate the air. You don't blow air in. Evacuating air out of that area is a much cleaner way to get rid of air, and it actually is a more efficient way to air because it'll pull air in from all around, all the cracks, the crevices, and exhaust it out one direction. So you get a much more efficient exhaust of heat by exhausting air, not blowing air in.
See, a question, is it common to tilt the instrument panel to match the pilot's eye point elevation?
Our field of view on our system is pretty great. You don't have to worry about tilting anything. I know some people have done it, but one of the nice things about the HDX system was that we kicked out that bottom bezel, and that gives you the ability to sort of rest your hand on it, plus gives you the ability to push down on buttons. So tilting that panel is really not a big advantageous thing to do in most aircraft installations. Again, I talked about field of view. The field of view on our LCD screen, we purposefully had the manufacturer increase that field of view along with the brightness so that for our application, so that pilots did not have to worry about washout with sunlight or off-axis angle viewing.
Yeah, and the angle, and if you think about how, you know, the only angle you really need to worry about is, you know, when the sun is going to hit your eyes. It's hard to protect against that, right? You kind of need to move your head around a little bit if you're going to get the sun right in your eyes. And that can happen, especially with a canopied aircraft, you know, no matter what. And if you do tilt it up, and if you think about the way things reflect off of glass, it's basically you know, just a symmetrical angle, right? So if it hits at 30 degrees, it's going to bounce off at 30. And so if you tilt it up, you're increasing the amount, the percentage of the time that you're going to have that in your eyes versus it falling off of, you know, below your eyes. So people do, this is totally a personal preference thing. but I would say most people do keep them relatively, flat on the panel.
Yeah.
Some of the Sonics guys in particular, not in David's panel, but the Sonics does have I think by default, right? It's an angled panel, and so that ends up being
angle, yeah.
15 degrees. Now I think you might have. Did you take that angle out in yours to make it
did.
more of a classic panel? See, so people have, so Weber wanted more of that flat angle. Some of it depends on, if you had an airplane that had a really low panel, you might want to tilt it up just for the sake of visibility. But again, we have really good view angles both side to side and top to bottom, so it's not that necessary.
What I would recommend is that you put that screen as high as you possibly can in the panel. I have seen installations where people will put the screen down lower in the panel and put modules on top of it. You want the screen as high up as you possibly can so that your eye movement is very little, very gradual compared to having to look down and actually do a head movement to look down at your instruments. If you're doing this in your panel, your head moving down, you've got something wrong in your panel. It should be an easy eye movement, not a head bob.
Yeah. Another question from J.E. Morgan, not J.P. Morgan. Is the ACU, the ACM, the Advanced Control Module, able to be purchased separately? Not by itself currently. That could change in the future. But what David was showing actually in where he's showing all the modules laid out with the harnesses, you can buy it just like that, what they call a panelless panel, where you're not getting the whole panel built up, but the ACM along with the ready to plug and play harnesses. So it is sold that way. And Advanced can tell you more about that if you wanted to buy it
Those
that way.
harnesses are get pretty complex. So I highly recommend that you do that. If you don't want them to build your panel, that is the way to go.
Yeah, and that's one of the reasons, the ACM is kind of built to be plug and play. And so right now, and Advanced is built, they've built the infrastructure to like have those harnesses ready to go. So when you get the ACM, you get at least all of the harnesses to go with it, and the panel if you want it. Let's see. There was a question about, somebody pointed out that we, this is me being bad at numbers. Apparently the 42 is the winner on the 41 drawing on the first drawing. I think we're just going to stick with those winners, and we'll do better next time.
Thanks for pointing out that.
Yeah. Again, once upon a time I had a math major, but apparently not tonight.
Harnesses. We do fabricate an intercom harness. And that is probably our most expensive harness, but it is also most complicated harness. That had iteration after iteration after iteration. Matter of fact, I still have all of my hair, but I think I lost a few follicles when I was designing that harness. Quite complex, but it's worth the money, and you won't find a better price on a harness that complicated anywhere else in the industry.
Yeah, but audio is kind of like RF. There's a lot of voodoo magic in there, in the sense that it's tricky. You've got shielding that matters. You've got sound, or induced currents that create noise, and even in the airplane, that Sportsman that David mentioned that I share with him and other Dynonians, when you turn on the strobes, you hear the whoop 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 whoop, which is just the electrical noise, very slightly high pitched. David might not be able to hear it because you're got a few years on me, but but that's sort of high pitched. So audio's voodoo magic. We make harnesses for that.
Yeah.
Let's see.
We won't mention who wired that up.
Yeah.
Mention
Wasn't me. Let's see. There's a question about, where was it? Autopilot status for certified aircraft like the Piper Comanche PA-24. So, yeah, the autopilot certification is airplane by airplane, unlike the almost 600. We obviously did install a system into nearly 600 models to get certified. You can do that based on an analysis. You can't do that with autopilot because of and need to engineer brackets to prove the installation, to literally flight test it, to demonstrate to the FAA and individualized documentation. So what we do have on dynoncertified.com is a list of currently approved airplanes, which are 172s and some Bonanzas. We've got the Piper Seneca, more Bonanzas behind that. And then after that, the C-182, the Mooney M20, and then beyond that, we've stopped publishing what we think we're going to do next because we have changed our mind. So you know, the usual suspects are the airplanes with higher volumes that are still out there that we have yet to do. Things like the PA-28 series, which is actually a lot of airplanes, even though it's a common type. It's not really all one airplane. There are groups like the Cardinal folks who are very well organized and have made a good case for doing the airplanes. But we're kind of not predicting out beyond what we are officially predicting at this point. But we do want to get to all of your airplanes, and especially the ones that have the volume and the audience that we can justify. So don't have that's kind of a weaselly answer, which is like I can't really say for any particular airplane beyond what we've published. My Dyna backup batteries have sat, unfortunately, for 3 years. Would you recommend the backup batteries have sat for 3 years? Would you recommend purchasing new ones before first flight? I have to believe they're completely discharged. Yeah, they probably. So yeah, so the deal with lithium ion.
Sorry, I was clearing my throat, but there was a question earlier about warranties, and batteries are one of the things that fall under the 1-year warranty, not the 3-year. So I wouldn't be surprised if those batteries need replacement.
Yeah, lithium ion batteries are good for hundreds of cycles. Caveat: if they are deeply discharged below some certain voltage, which can happen if they just sit, that can induce permanent damage. And ironically, if you leave them at full charge during storage, that'll reduce their lifespan as well. The best thing to do is to fully charge them. The best way to do that is to get your Skyview with the battery connected on a charger, like a aircraft battery charger with your aircraft battery connected. So Skyview needs to see, I think it's 12.5 volts before it will try to charge the connected backup battery, and that's so that it doesn't drag down your aircraft battery when your engine's not running. So it wants to see an alternator-like device. Any battery charger for your aircraft battery is going to give you a high enough voltage, and charge that battery overnight if you can. It'll take 10 to 12 hours, I think. Maybe it's only like 4, but basically give it a good long charge session on an external charger, and then do there's a rundown test that Skyview is capable of performing. So once you have that battery fully charged, and Skyview will know if it's fully charged, see how the battery's doing. If it doesn't last the test, which is 45 minutes, and it should last more than an hour, but 45 minutes is kind of the threshold for when it'll fail the test, then it's time to replace that backup battery. It isn't necessarily damaged, though. It could be. Yeah, three years is a while.
Maybe don't count on that for your first flight, but it more than likely will. Well, I don't say more than likely. There's a chance it could charge and come back to life.
Yeah.
I think it's 12.25 volts is the kickover. Looks for 12.25. Then it feels it has enough power to charge.
Yeah. Any other questions from anyone out there? If you'd like to ask a question, you could raise your hand. You could type it into the Zoom. Otherwise, we're at 6 o'clock. That's an even 2 hours. Pretty good distance for this. I'm replacing a legacy radio. Can I replace it with a Dynon radio? Yeah. So yes, if you have Skyview. So the Dynon radio, for a few reasons, isn't designed to be standalone. So it pulls database information from Skyview. The best experience is going to be with when it's connected with Skyview. There are some settings that cannot be set via the radio interface itself, things like squelch and things like that. So you really want to have Skyview in the mix. So if you have Skyview in the mix, then by all means, you could bring assuming you mean comm radio. If you mean nav radio, we don't have currently a nav radio to offer.
Mike, I sent him an unmute request to see if he wanted to chime in more on specifically his question, since it's a little quiet. Danny, are you there? I see you. I don't hear you. Nope, he's remuted. No. We can follow up with you, Danny, and get you a better answer depending on what your question was.
All right, and with that, I think at 6 o'clock we'll wrap it up for the evening. And again, this will be archived on our Facebook videos page and also YouTube in a couple of days, and eventually we'll have it up on our website on a gallery so you can come back and revisit this. And we do have more programs the rest of the week. Tomorrow is Advanced Flight Systems Day, AF 5000 at 2 o'clock, at 4 o'clock Advanced Panel, which is the panel, or the panelist panel that includes the advanced control module. Friday's the Skyview HDX virtual booth visit where we'll demonstrate the Skyview, and then Saturday's our hangar happy hour. So please join us. They're all of them except the advanced one tomorrow starts at 2. Everything else starts at 4, just like today's. You can sign up on our website, and we'd love to see you. And thanks for coming by, everybody, today.